So today we're going to be putting together that last piece of kind of the puzzle for graphing rational functions. So you guys should have this notes here packet, and we're going to be kind of filling it in and going over the examples. So you're graphing rational functions, and the last piece is to do sign charts. The sign chart is what will help you put together all of those pieces without using Desmos and to know exactly how your graph is going to look. So if you recall, last class period, I had you guys take out these cards, the laminated cards, and I wanted you guys to see where do the graphs go from being below the x-axis to above the x-axis. So below x-axis, above x-axis. Well, here it changes from being below to above at an x-intercept. Above the x-axis, below the x-axis. Here it makes that change at an x-intercept. If you look at the next graphs, here we have above the x-axis, and then you have this part down here below the x-axis. So here it goes from being above the x-axis to below the x-axis at a vertical asymptote. Here's below the x-axis. This part's actually below the x-axis. This part here is above, and this part here is above. So this first part here, right there, that goes from above to below. Oops. At a vertical asymptote. So I'm just unhighlight. Why aren't you doing that? So this next piece here goes from below to above at a vertical asymptote, and the last piece, the yellow to green, goes from above to below at an x-intercept. If you look down here, again, we've got, let's see here, this part's below, 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 and then this part here is above, this part's above, and this part here is above. Now the yellow to green, it changes at an x-intercept. Green to yellow goes from above to below at a vertical asymptote. This yellow to green in the middle changes at an x-intercept. Green to yellow changes at another x-intercept, and then this last yellow part to green part changes at a vertical asymptote. So the whole point is that a graph goes from being below the x-axis to above the x-axis at either an x-intercept or a vertical asymptote. So over here, you can kind of make that note on this worksheet and say changes from below to above x-axis at an x-intercept or a vertical asymptote. So those are the two spots where it changes. Now, to graph a rational function, you find and graph the x and y intercepts, the vertical asymptotes and holes, and the horizontal asymptotes, and we've done that already. So it says the last piece needed to sketch a graph is a sign chart. Sign chart allows you to determine when the graph is above or below the x-axis. So really what we need to find are where are x-intercepts and where are the vertical asymptotes. So let's go through this first example here. So sign chart directions. So first, fully factor the rational function and find all of the zeros of all of the factors of both the numerator and the denominator. So really the goal is find the x-intercepts, find the vertical asymptotes. So I'm going to factor this. So this becomes x plus 2 times x plus 1 all over x plus 1 times x minus 1. Now, I know that I'm going to have a vertical asymptote at x equals 1, and I'm going to have an x-intercept at x equals -2. So I've got an x-intercept at -2 and a vertical asymptote at 1. This part's going to cross off because it's a hole. So I'm going to make my sign chart. Now what you want to do is make a number line and plot the zeros on the line. So the zeros are basically like whatever makes the numerator equal 0, whatever makes the denominator equal 0. So I know that the numerator is going to equal 0 at -2. So I'm going to put that guy on here. And I know the denominator is going to equal 0 at +1. This -2 represents where I have an x-intercept, and this +1 represents where I have a vertical asymptote. And over here you can kind of see, here's my x-intercept, here's my vertical asymptote. If you wanted to have found your y-intercept is right here. And your horizontal asymptote, if you wanted to, find and plot that, that's right there, that diagonal line. So to piece this together, I need to know, is it above or is it below? So what I'm going to do is plug in -2, plot -2 and 1. Along the left side, list all of the factors, numerator and denominator, of the function. This includes coefficients and all powers of the factors. So I'm going to list x plus 2 times x plus 1, because those are from the numerator, even though I crossed it out, x plus 1 and x minus 1 here. Now the idea is, I want to determine this function when it's from -2 down here to -infinity, is it going to be above or below the graph? Well, all you have to do to determine that is plug in an x value on that domain. So pick -4 or -5 or -6, plug it in the function and see if it's positive or negative. If it's positive, that means it's above the x-axis. If it's negative, that means it's below. So imagine that I take this function here, x plus 2 times x plus 1 divided by x plus 1 times x minus 1, and I plug in like -3, let's say. Any value from -2 to -infinity would work. So I'm just going to pick -3 because I'm picking something along this first interval here. So I'm picking something in between -2 and -infinity. Let's say I pick -3. Well, all I really care about is when I plug in -3, does it give me a positive or a negative answer? So imagine plugging in -3 here. -3 minus 1 gives you -4. So I know that's going to be negative. -3 plus 1. -3 plus 1 is -2, so I know that's negative. -3 plus 1 again, that's going to be negative. And -3 plus 2, that's also going to be negative. So a negative times a negative divided by a negative times a negative, that's all going to give me a positive. So I know that this region from -infinity to -2 has to be above the x-axis. So this part here I would draw in above. Okay, and you can kind of see it's already there. I'm just showing that it matches. Now let's do the same thing for this region between -2 and 1. So I want to know from -2 to +1 where this horizontal or this vertical asymptote is. Is that going to be above or below the x-axis? So in other words, are those y values positive or negative? So I'm going to do the same thing. I'm going to pick a number, an x value between -2 and 1. So I'm going to pick 0. Imagine plugging in 0. 0 minus 1 is -1, so it's negative. 0 plus 1 is positive. 0 plus 1 is positive. 0 plus 2 is positive. So a negative times a positive, which is my numerator, divided by a positive times a positive, well, that's going to give me a negative number. So I know that if I come over to my graph, between -2 and +1, which is this part, my graph is going to be below the x-axis because that ended up giving me negative y values. Now the only region that's left here is this part to the right from 1 to infinity. So I'm going to pick an x value in that region, let's say 2. If I plug it into my function, 2 minus 1 is 1, so it's positive. 2 plus 1 is 3, so that's positive. 2 plus 1 is 3, that's positive. 2 plus 2 is 4, that's positive. Well, 4 positives is going to give me positive value. So I know that this part of the graph to the right is going to go above the x-axis. Okay? And so that's how I know how that graph looks. So let's look at another example here. So here we've already found all the pieces to this graph and plotted them, and now you have to imagine that we're just trying to figure out where these go, above or below the x-axis. So I'm going to factor the numerator, x plus 3 times x minus 3, divided by x plus 4 times x minus 4. And I'm going to make my sign chart. Now I know that I'm going to have an x-intercept at -3, because if I make y equals 0, I end up getting -3. And I'm going to have vertical asymptote at -4, so I guess I should put this first. So -4, -3. I know that at +3 I'll have an x-intercept, and at +4 I'll have an x-intercept. And I'm going to list my factors along the side. X plus 3, x minus 3, x plus 4, x minus 4. Now I want to know on these regions, for example, between -4 and -infinity, is my graph above or below the x-axis? So when my x values are from -4 to -infinity, where are my y values, above or below? Well, if I pick an x to plug into this function to see what my y is, I could pick like -5. Okay, -5 minus 4 is going to be a negative number. -5 plus 4 is going to be negative. -5 minus 3 is going to be negative. And -5 plus 3 is going to be negative. Well, 4 negative is going to end up giving me a positive value. So that's how I know that from -infinity to that vertical asymptote at -4, I know that's going to be a positive value above the x-axis. Okay, now from -4 to -3, let's say I put in -3.5. So -3.5 minus 4 is going to be negative. -3.5 plus 4 is going to be positive. -3.5 minus 3, negative. -3.5 plus 3 is going to be negative. So 3 negatives and a positive end up giving me negative values. So I know that from this value of -4 all the way up to this x-intercept of -3, which is right here, my function is going to be below the x-axis. Here, from -3 to 3, I want to know is my function above or below the x-axis. So I'm going to pick an x value, I'm going to use 0, and plug it in. 0 minus 4 is negative, 0 plus 4 is positive, 0 minus 3 is negative, 0 plus 3 is positive. Negative, positive ends up giving me positive. So I know that on that interval, from -3 to +3, function's going to be above the x-axis. Now you keep going, you do the same thing. From +3 to 4, let's pick an x value, plug it in. Let's do 3.5. 3.5 minus 4 is negative. 3.5 plus 4 is positive. 3.5 minus 3 is positive. And 3.5 plus 3 is positive. Well, one negative and 3 positives gives you a negative. So that part of the graph must be below the x-axis. And then last but not least, we've got the part from 4 to infinity. So from 4 to infinity, We want to know, is it above or below the x-axis? So I'm going to plug in 5. 5 minus 4 is positive. 5 plus 4 is positive. 5 minus 3 is positive. And 5 plus 3 is positive. So 4 positives gives me a positive. So I know that over here, this part of your graph is going to be above the x-axis. It's going to go there. Okay. Let's do another example. So we want to find the x-intercepts, the vertical asymptotes, holes, horizontal asymptotes, graph it, make a sign chart, sketch the graph. So here we're doing everything. So let's start out. I'm going to distribute this inside. So this becomes y equals x squared plus 5x plus 6. The denominator becomes x squared minus x. So I've got my factored form and my non-factored form. So horizontal asymptote is what I'm going to start with. My horizontal asymptote, remember Bobo Botan eats DC, bigger on bottom, bigger on top, or exponents are the same. So here we've got the same degree in the numerator and denominator, so exponents are the same. Well, that means that my horizontal asymptote, I'm just going to divide my leading coefficient, so 1 over 1. So y equals 1. Remember, I'm writing it as an equation of the horizontal line. So at y equals 1, I'm going to have my horizontal asymptote. So that's going to go there. Okay, now let's come back. The next easiest thing to find is your y-intercept. So y-intercept, you just plug in 0 for x, 0, 0, 0, 0. I end up with 6 divided by 0, which is undefined. So there is no y-intercept. All right, now let's move on. Vertical asymptotes. So vertical asymptotes are where just the denominator equals 0. Well, that's going to happen at when x equals 1. So the equation of that line is x equals 1. Box it in. I'm going to graph that over here. So at x equals 1, I have a vertical asymptote. Now I also have a vertical asymptote at x equals 0. Because 0 also makes only the denominator equal 0. So I have another vertical asymptote here. That factors only in the denominator, and this other factors also only in the denominator. Okay. Now, we've got, let's see here what I'm missing, holes. So holes are where you have like the repeated factor. Well, there's nowhere that the numerator and the denominator both equal 0. There's no factor that's in the top and the bottom. So there are no holes. And then last but not least, we've got our x-intercepts. Now remember I said with x-intercepts, you cross off the common factors, which there aren't any, and then you substitute 0 for y. So you have 0 equals x plus 2 times x plus 3 divided by x times x minus 1. Multiply both sides by the denominator, and you get 0 equals x plus 2 times x plus 3. So you have negative 2 comma 0 as an x-intercept and negative 3 comma 0 as an x-intercept. So I'm going to plot those points, negative 2 comma 0 and negative 3 comma 0. Now remember what we learned. We learned that your graph will go from above the x-axis to below the x-axis at a vertical asymptote or at an x-intercept. So those are the values that go on the bottom of our sign chart. So those values are negative 2, 0, 1, and 3. Now I want to know, is the graph above or below the x-axis on those intervals? So from negative 2 to negative infinity, I need to pick an x value and plug it in. So I'm going to write my factors on the side. and plug in a value. So let's think about -3. Well, -3, give me a second here. What happened? Oh, -3 is another x-intercept, that's right. -2 and -3 are x-intercepts. 0, 1, I plotted it in the wrong spot. Okay, I'm going to erase this guy. All right, moving along. So I've got -3. -3, -2, 0, and 1. -3, -2, 0, and 1. So from -3 to -infinity, let's think about -4. If I plug in -4, -4 plus 3 is negative, -4 plus 2 is negative, -4 minus 1 is negative, and -4 is negative. So 4 negatives make a positive. So what that means is that from -infinity to 3, your graph is above the x-axis. So it's going to look something like that. Now from -3 to -2, I'm going to pick -2.5. So -2.5 plus 3 is positive. -2.5 plus 2 is negative. -2.5 minus 1 is negative. And -2.5 is negative. So this ends up being a positive and 3 negatives gives you negative. Okay, here we have positive, here we have negative. So I know that my function is going to be negative here. So it's probably going to like dip down and come back up. Now between -2 and 0, I want to find out what happens. So I'm going to plug in -1. All right, so between -2 and 0, we have let's see here, -1. So I'm going to plug in -1 plus 3 is positive, -1 plus 2 is positive, -1 minus 1 is negative, and then -1 is negative. So positive, positive, negative, negative gives you a positive. That means this function is going to stay above the x-axis. So it's going to look something like this. I know this is kind of weird, but remember that it's allowed to cross over the y horizontal asymptotes. And so that's what it looks like there. Now between 0 and 1, if I use a half plus 3 is positive, a half plus 2 is positive, a half minus 1 is negative, and a half is positive. So that means it's going to be negative there. Positive, positive, negative, positive gives you a negative. So this is what your graph is going to look like. It's not going to cross over the x-axis because there's not an extra x-intercept there, so it's going to stop at the x-axis and come back down. Now from 1 to infinity over here, we can pick like 2. 2 plus 3 is positive, 2 plus 2 is positive, 2 minus 1 is positive, and 2 is positive. So this is going to stay positive here. So from 1 to infinity, it's going to be positive. It's going to look something like that. Okay? Moving on. So last example here. So it's the same concept. I'm going to factor the numerator. So we get 3 times x plus 2 times x plus 1 over x plus 1 times x minus 1. So I got to find all of my pieces. So this part here, if I multiply it in, is 3x squared plus 9x plus 6. First, I'm going to look at my horizontal asymptote. So exponents are the same, so I'm going to divide my leading coefficient. So we have a horizontal asymptote at y equals 3. Next, I'm going to do the y-intercepts. So y-intercept, I'm going to plug 0 in for all my x's. End up getting y equals 6 over -1, so -6. So 0, -6 is your y-intercept. And now you need to use the factored version for everything else. So vertical asymptotes, those occur where just the denominator equals 0, so we have +1. So x equals 1 is the equation of that vertical line. Then if I look at the wholes occur where the numerator and denominator equals 0, so that'd be -1. To find the y value, have to cancel out and then plug in. So y equals 3 times negative 1 plus 2 divided by negative 1 minus 1. So you get 3 times 1 over negative 2, which gives you negative 3 halves. So your whole is negative 1 comma negative 3 halves. And then the last piece are your x-intercepts. So remember, you cross out first and then substitute 0 for y. So 0 equals 3 times x plus 2 over x minus 1. Multiply by x minus 1 on both sides, you get 0 equals 3 times x plus 2. So you end up with x equals negative 2. So negative 2 comma 0 is your x-intercept. And I'm going to plot all this stuff. So we've got horizontal asymptote at y equals 3. So there's that guy. Y-intercept is 0 comma negative 6. Vertical asymptote at x equals 1. Whole at negative 1 comma negative 3 halves, so about there. And an x-intercept at negative 2 comma 0. Now we're going to do the sign chart to figure out where it's above the x-axis and where it's below the x-axis. So remember, it changes from above to below at x-intercepts and at vertical asymptotes. So negative 2, and then a vertical asymptote at positive 1. So from negative 2 to negative infinity, well, first of all, let me list out my factors. So we've got x plus 2 times x plus 1, and then x plus 1, x minus 1, and then we also have a factor of 3 in the numerator. So 3 is always going to be positive. I'm going to use negative 3 as my x value. Negative 3 minus 1 is negative 4, so that's negative. Negative 3 plus 1 is negative. Negative 3 plus 1 is negative. And negative 3 plus 2 is negative. So 4 negatives and a positive, that's going to give us positive values. So here, where from negative 2 to infinity, this graph is above the x-axis, like that. Change my colors. Okay. Now let's come back here, finish our sign chart. So from negative 2 to 1, I'm going to use an x value of 0. So 3 is always positive. 0 minus 1 is negative. 0 plus 1 is positive. 0 plus 1 is positive. And 0 plus 2 is positive. So we've got 4 positives and a negative. That's going to make it negative. So that means that the graph is going to go below the x-axis from negative 2 to positive 1. So it's going to look something like that. There's negative 2 and positive 1. And now our last interval is from 1 to infinity. So I'm going to pick 2 as my x value to plug in. 3 is always positive, so that's positive. 2 minus 1 is 1. 2 plus 1 is 3, so that's positive. 2 plus 1 is 3, so that's positive. 2 plus 2 is 4, so that's positive. 5 positive values gives you a positive, so I know that from 1 to infinity, this graph is going to be above the x-axis up here. Okay, and that's it. That's your last example. Pretty sure, just double check. Yep, that's it.